Welcome to solverfy.
So here we're going to say that the energy at the top is equal to the energy at the bottom due to the law of conservation of energy. Therefore, mgy at the top will be equal to mgy at the bottom plus 1/2 kx of the bottom squared. And at this point, to find k is going to be equal to 2mg delta y divided by x at the bottom squared. And we can solve. So this will be 2 times 62 kilograms times 9.8 meters per second squared times the change in height. So this will be 20 meters minus negative 1.1 meters. And then this will be divided by 1.1 meters quantity squared. And we find that the spring constant is 2.119 times 10 to the 4th newtons per meter. Now, for part A, we simply want the external force. Rather, we want the x distance. So how much does it stretch? So here for part A, we know that the external force is going to be equal to the spring constant times the compression. So x is simply going to be equal to mg over k. And this will equal 62 kilograms times 9.8 meters per second squared. And then this is being divided by 2.119 times 10 to the 4th newtons per meter. And we find that the x position is 0.029 meters. So this would be your answer for part A. And then for part B, we know that y at the top now is going to equal 38 meters. And we're saying that y at the bottom will equal negative x. Therefore, again, mgy at the top equals mgy at the bottom plus 1/2 kx squared. So we can say that x squared minus 2mgx over k minus 2mgy top over k. And so essentially, this is going to be equal to 0. This is a quadratic equation, so we can simply just say x squared minus 2 times 62 times 9.8 times x divided by 2.119 times 10 to the 4th, and then this will be minus 2 times 62 times 9.8 times 38 meters divided by, again, 2.119 times 10 to the 4th newtons per meter. This is going to equal 0. You can use the solve function on your TI-84, TI-85, or TI-89 in order to solve for x. And x is simply going to be equal to 1.505 meters. So this would be our final answer. That is the end of the solution. Thank you for watching.